Yalah, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Today I will be presenting the network topology that I have designed for Ccnp Superlab assignment. Uh, the first assignment. This topology was created to test my understanding of the use of various routing protocol in a single network, as well as how various configuration can affect data flow and network efficiency. The description of topology and network components. This topology consists of 5 routers connected through multiple subnets, as well as to virtual PCS or VPGs placed at the end of the network to simulate end users. Each router in this topology has a different role and configuration to reflect a real scenario and enterprise environment. Okay. Next to the first step in the router one is connected to two main subnets, which connect it to the VPC on the left and 30.30.30.30.0/24, which connects into it to router 3. On this router, I configured Eigrp with unbalanced load balancing. This configuration allows that router to distribute traffic unevenly among multiple paths to the destination, namely network 4.4.4.0/24 and 45.0.0.0/8. This is an implementation of the delay variable where I have added a delay of 10,000 milliseconds on the path to network 30.30.30.0/24. This router will be considered less favorable than the other available paths. Router 2. Router 2 operates using OSPF with a configuration in area 0. OSPF is used here to ensure fast configurance and efficiency in router determination. Router to connect network 2.2.2.2 slash 32 with the core network and has interconnection with router 1 and router 4 via subnets 12.12.12/24 and 24.24.24.0/24. The use of OSPF here helps is managing routes and at a large scale. Keep routing stable and efficient, especially in the dynamic router environment. Routing RIP version 2 was chosen to distribute routes to network 33/32 and several other subnets such as 30.30.10 to 30.30.40. RIP is known for its ease of setup, but the limits with limits in terms of the size of the network that can be managed is in this scenario. RIP is used to show how this older and simpler protocol can still work in a smaller or segment environment within a large network. Router 4. Router 4 server as the link between some subnets and other routers such as router 3 and router 5. Router 4 manage subnets 34.34/24 and 24.24/24 and communicates with router 3 and router 5. It also forwards traffic to network 44/33, which is managed by router 5. That the main function of router 4 is to ensure that router between network can be distributed effectively, maintain network continuity. Router 5. Finally, router 5 is set to provide a summary default route to network 50/50/50/24, which include host addresses 50/50, 10 to 50/50/40. This router is connected to the 45/45 subnet and also manage the uh, 100 uh, manage the IP 5.0/24. Subnets to which the VPC on the right is connected by configuring summary routes. Here, I am attempting to simplify the routing table. Simplify the routing table. Wait. Simplify the routing table, especially when dealing with a large number of subnets connected via single path. Analysis of the configuration and its effects. Now let's dive deeper into some of the specific configuration efficiently. Unload balancing Eigrp R1 is configuration allow router 1 to analyze more than one path to the destination, but with different preference that path with lower delay will be chosen more often. This can be useful in real life scenario with where the primary path may experience overload or interface, and the secondary path can take over without significantly impacting network performance. OSPF Area 0 deployment in Router 2. OSPF is well known for its ability to efficiently manage routes in large network by placing Router 2 in Area 0. I ensure that it became the backbone for all OSPF router in this network. This allows for fast convergence and efficiency route management. RIPv2 implementation on Route 3, although RIP as a simpler protocol and has a limitation in terms of scalability. It used in Router 3, it means to show how it can be in integrated in larger and more complex networks. It also demonstrates the importance of understanding various protocols, even older ones, as they are still relevant in current scenarios. Summary default in router 5. By configuring summary in router 5, it was able to reduce the number of entires in the routing table, thus making the routing process more efficient. This is a very useful technique in large-scale network, where manually managing a router can become very complicated. So for the conclusion, this technology depicts a complex yet realistic network scenario, combining the following. Maybe this is how I can explain to you. Dan saya, Assalamualaikum warahmatullahi wabarakatuh.